Okay, I think we're going to go ahead and get started. First off, I want to thank everyone and welcome everyone and thank you for attending. This is part one of a three-part series where we are going to explore the recent HAProxy 2.0 release and other related announcements, including the new data plane API and the HAProxy Kubernetes Ingress Controller. I have Daniel Corbett, who will be presenting today's session, which is Exploring HAProxy 2.0, Take a Tour Through the New Features. Next Tuesday, July 9th, we will be presenting the HAProxy Kubernetes Ingress Controller for high performance ingress. And then the Tuesday after that, July 16th, we'll present HAProxy Data Plane API, the true dynamic configuration management. So be sure to return for those topics. During today's presentation, if you have a question, you can enter it into the questions tab on your GoToWebinar window. Then at the end, we'll have a chance to answer those questions. We're also going to be publishing several blog posts related to HAProxy 2.0, so if you haven't already, pay attention to our Twitter feed so you can see when those are published. So I'm happy to introduce Daniel Corbett. Daniel is Director of Product at HAProxy Technologies. HAProxy Technologies is the largest contributor to the open source HAProxy project, and Daniel's role involves prioritizing features as well as ensuring that the open source community is being served. You will often find him answering technical questions on the HAProxy Slack. So Daniel, do you want to take it away?
Hello, everyone, and thanks, Nick. I appreciate it. Welcome to this webinar on exploring HAProxy 2.0. We're extremely excited about this release as HAProxy 2.0 makes it easier to configure, extend, and manage HAProxy in cloud-native and containerized environments. I'll be giving you a tour of some of the newest features you can expect to see within HAProxy. In this specific section, HAProxy 2.0 will deliver better performance and reliability. It features cloud-native threading, end-to-end HTTP2, gRPC, and layer 7 retries. Traditionally, HAProxy has supported multi-process mode using the NBproc directive. In HAProxy 1.8, multi-threading was introduced. HAProxy 1.9 further improved this by allowing a large amount of threads to be used. However, it was found that some users were not tuning the NB thread settings correctly, and at times this was resulting in less than ideal performance. HAProxy 2.0 simplifies this by automatically configuring itself to spread across all available cores. This means that manually configuring of NB thread is no longer required. Also, the bind lines are automatically bound to each thread. Two new build parameters have also been introduced, which are helpful on embedded devices, which may not need to support a maximum threads of 64. HAProxy 1.9 introduced HTX, which is an internal native representation of the HTTP protocol. This allowed HAProxy to introduce support for end-to-end HTTP2, and in the future, it will lay the foundation for supporting other HTTP-based protocols, such as HTTP3, also known as QUIC. Here's a short configuration snippet that shows you how you can begin using end-to-end HTTP2 today. Following end-to-end HTTP2 support, HAProxy 2.0 introduced support for gRPC. This includes bidirectional streaming of data, detection of gRPC messages and routing based on this data, as well as logging of gRPC traffic. Here's a sample configuration which shows HAProxy matching the path /another service /some function and sending it to a specific backend when matched. Traditionally, HAProxy has supported layer 4 retries using option redispatch. Now it supports layer 7 retries, which allows HAProxy to retry a request which has encountered a server error. Examples of such errors could be a specific status code such as a 500 or a 400 based error, an empty or a junk response, or a response timeout. It also features a directive, all retriable errors, as seen in the configuration snippet, which is the equivalent to specifying to retry on connection failure empty response, junk response, response timeout, 0 RTT, rejected, or any of the 500 based errors. It is important that you know how your application behaves with layer 7 retries enabled. Caution must be exercised when retrying requests such as post requests. In the example shown, we have disabled post requests from being retried using the HTTP request disable L7 retry directive. Traditionally, HAProxy has had support for TCP fast open on the front end, and this has been available since version 1.5. It now supports end-to-end TCP fast open by offering it on the back end as well. The benefit of this is that you save one round trip after the first connection. You can take advantage of this by adding the TFO parameter to the server line as shown in the configuration snippet. Please be aware that this requires Linux kernel 4.11 or newer. HAProxy 2.0 features easier management and extensibility, and in conjunction with this release comes the HAProxy data plane API, as well as a process manager, polyglot extensibility, and support for traffic shadowing. The new HAProxy data plane API provides a modern REST API for configuring HAProxy on the fly. It allows you to dynamically add and remove front ends, back ends, and servers. You can also create ACL rules, insert HTTP routing directives, set IP and port bindings, and much more. The API updates the configuration file and reloads as needed, while also taking advantage of the runtime API. The data plane API runs as a sidecar process, which HAProxy can manage using the program directive in the new process manager. Here, you will see a link to the GitHub where you can get started right away. To learn more about the data plane API, please attend our webinar, which will be hosted on July 16th, 2019. Sign up at the link on the screen. This release introduces support for the new process manager, which allows you to specify external binaries that HAProxy will start and manage directly under its master worker mode. This is done by using the new program directive within the configuration by passing the path to the executable along with its arguments. You can view a list of the running commands by issuing a show proc command from the runtime API. Here's a screenshot of how that show proc command would look. Here you can see we have two programs specified. One is the data plane API, and the other is our SPOA mirror. The stream processing offload engine and the stream processing offload protocol were introduced in HAProxy 1.7. The goal is to make it possible to build upon HAProxy using any programming language. It can be used to set variables directly within HAProxy, which can then be used for routing decisions. Stream processing offload agents can also be scaled horizontally. In the image shown, you'll see how the flow of traffic would work when using the stream processing offload engine to communicate over the stream processing offload protocol to a stream processing offload agent. Here are a few samples of some of the community projects which are available to begin building your own stream processing offload agent in the language of your choice. As you can see, there are examples for .NET, C, Golang, Lua, and Python. If your preferred language is not listed, don't worry. You can create your own integration as long as it can communicate using the stream processing offload protocol. Traffic shadowing, or mirroring, allows you to mirror requests from one environment to another. This is helpful in instances where you would like to send a percentage of production traffic to a testing or staging environment. The new daemon was created as a stream processing offload agent and can also be managed using the built-in process manager. Here's an example of how the flow of traffic would look with traffic shadowing enabled. As we can see, the client comes in and HAProxy sends its request to our production server, but it also will send a copy of the request to the staging server. Please note that the response from the staging server is disregarded. In this section, I'll cover our new release of the HAProxy Kubernetes Ingress Controller. The new HAProxy Kubernetes Ingress Controller provides a high-performance ingress for your Kubernetes hosted applications. It supports TLS offloading, layer 7 routing, rate limiting, whitelisting, and the best-in-class performance that HAProxy is renowned for. Ingresses can be configured through either config map resources or annotations, and there's support for defining secrets for storing TLS certificates. You can find it on GitHub at the link shown, and also sign up for the webinar, which will be hosted on July 9th, 2019. HAProxy features next-level observability, and it adds on to this with this release featuring cloud-native logging, a native Prometheus exporter, peers and stick tables improvements, log distribution and sampling, as well as a built-in automatic profiling. Logging is now easier to adapt for containerized environments. You can log directly to stdout, stderr, or to a file descriptor. The configuration shown provides an example of how to implement this. HAProxy now has native support for exposing metrics to Prometheus. Prometheus is an open source systems monitoring and alerting toolkit that was originally built at SoundCloud. Its adoption has been widespread and it inspires an active community. Check out the blog post shown on the screen for more detailed information on how to begin using the built-in Prometheus integration. I've also included a configuration snippet which tells you how you can implement the native Prometheus exporter within your existing stats front end. HAProxy allows propagation of stick table data to other HAProxy nodes using the peers protocol. Nodes configured to use the peers protocol will now send a heartbeat message to its peers after a 3-second period of inactivity. If there isn't any activity within a 5-second period, the peer is considered dead. The peers section has been expanded to allow using the bind, default bind, server, and default server configuration directives. It also now supports having stick tables directly within itself. This means that you no longer need to use dummy backends as previously recommended when dealing with many different stick tables. It also supports encrypting traffic between nodes using SSL, as well as introduces a new runtime API command, show peers. With HAProxy 2.0, you can now do log sampling directly within HAProxy by using the log directive sample parameter. Multiple log and sample directives can be specified simultaneously. The first log line parameter shown configures all local 0 logs to be sent to stder. The second log line shown configures logging to localhost on port 10,001 at a sampled rate. 1 out of 10 requests would be logged to this source. The third log line configures logging to localhost on port 10,002 at a sampled rate as well. For every 11 requests, it will log requests 2, 3, and 8 through 11. HAProxy 1.9 introduced profiling. HAProxy 2.0 expands on this profiling by allowing the auto parameter to be specified, which activates automatically when a process starts suffering from average latency of 1,000 microseconds or higher, as reported in average loop US. This can be configured using the profiling.task directive within the global section. You can also use the show activity and the show profiling runtime API commands. Some other improvements that have been made within HAProxy 2.0 are support for power of 2 random choices load balancing algorithm, new HTTP request and TCP request actions, new converters, new fetches, miscellaneous improvements, as well as long-term stable support for 1.9 features. In the 1.9 release, a new load balancing algorithm was added called random. It chooses a random number as the key for consistent hashing function. Random load balancing can be useful with large farms or when servers are frequently added or removed, as it may avoid the hammering effect that could result from round robin or least con in this situation. It also respects server weights and dynamic weight changes, and server additions take effect immediately. The hash balance factor directive can be used to further improve the fairness of the load balancing, especially in situations where servers show highly variable response times. When setting balance to random, the argument draws indicates that HAProxy should draw that many random servers and then select the one that is least loaded. Drawing 2 servers is what gives support for the power of 2 random choices algorithm. In the configuration snippet shown, you could see that we are passing 2 to the random algorithm, which should do the power of 2 random choices load balancing. Some additional HTTP request and TCP request actions have been added. Specifically, using HTTP request or TCP request, you can now use the action do-resolve to resolve a host name to either an IP4 or an IP6 address. You can also now, using TCP request, set the destination to an IP specified or set the destination port to a port specified. This allows you to dynamically connect to backend servers by using the data found from the do-resolve action. And as mentioned previously, a new HTTP request action, disable L7 retry, has been introduced to conditionally disable layer 7 retries. Converters allow you to transform data within HAProxy and are usually followed after a fetch. Here are some of the new converters you can expect to see within HAProxy 2.0. The first converter, AES GCM DEC, decrypts the raw byte input using an AES GCM cipher suite. You can also use protobuf to extract the raw field of an input binary sample representation of a protocol buffer's message, or gRPC, to extract the raw field of an input binary sample representation of a gRPC message. Both of these converters are typically used within gRPC-based requests. Fetches provide a source of information from either an internal state or from layers 4, 5, 6, and 7. Here are several new fetches that have been released in HAProxy 2.0, which allows returning client random data, server random data from either a front end or a back end when a connection is made over SSL or TLS. These can be useful to decrypt traffic sent using ephemeral ciphers. Several miscellaneous improvements have been made, such as TLS ticket keys now support AES 256-bit, and this can be updated through either a file or the runtime API. We've also introduced a new global directive, set dumpable, which makes it much easier to retrieve a core dump from HAProxy, as it should help with some of the system tunings that are often needed to produce a core dump. You can now also use the SOX4 keyword or the check via SOX4 keyword on a server line, which will allow you to connect to a SOX4 based server. HAProxy 2.0 is an LTS release and features LTS support for some of the 1.9 features, such as a small object cache, which can now be used with a maximum storage of 4 GB. This can be configured using the new directive, total max size, and individual objects can be no larger than half of the maximum storage of 4 GB. It also added support for connection pooling to backend servers, as well as HTTP 103 early hints, which is going to be the replacement for what is known as HTTP 2 push. You can also, since 1.9, use priority control over the server queue to help control the priority of specific connections that are within the queue of HAProxy. The DNS resolver section now supports using resolve.conf, and within Lua, the server class has gained the ability to change a server's maxcon value, and the TXN class has gained the ability to adjust the connection's priority within the queue, as mentioned by the server queue priority control. A new stick table class allows access to the content of a stick table, which can allow you to export or dump stick tables within HAProxy. I hope you enjoyed watching this webinar and getting a tour of HAProxy 2.0. Please, we'll open it up for questions now. Nick, do you have any questions?
Thanks, Daniel. That was really great. So, and I was kind of taking notes as you were going through your presentation, and these are just some of the topics to, as people are getting their questions. You covered observability, where you're talking about logging to standard out, whereas before HAProxy would log to syslog, and I know that people have asked for a way to log to standard out for if they're running HAProxy in a container. That's been something that people have been wanting to see. You talked about logging samples of traffic, so if you don't want to log all of your requests, you can just sample some of the traffic for logging. You talk about profiling as another area for observability. Reliability, so layer 7 retries are now built in. You can allow retries if there's an HTTP error. There's traffic shadowing, so if you want to mirror traffic, production traffic to a QA or a staging server, you can use the traffic shadowing SPOA agent. You covered extensibility through the stream processing offload protocol, for which there are a couple of different languages that you can use to extend HAProxy, in addition to building new languages onto that. You talked about performance, so TCP fast open, gRPC support, automatic threading, and the new random load balancing algorithm. New actions such as do resolve, so that you can actually resolve a DNS hostname per request, which is really interesting. HAProxy has had the ability to resolve DNS addresses at runtime using the resolvers section, but this goes even farther than that, allowing you to resolve per HTTP request. So kind of opens up some interesting scenarios. There are new converters for deciphering protobuf and gRPC, as well as new fetches, and then even SOX 4 support. So there's a lot of good stuff in this release. So if anyone has questions about those, go ahead and enter them now, and we'll try to get through as many as we can.
That was a great synopsis. Thanks, Nick.
So one question that we have is, what changes would someone need to do for an HAProxy.cfg file to be compatible with 2.0?
We typically try to make sure that new versions of HAProxy are backwards compatible. So I wouldn't really expect you to have to make many changes. But if you are using directives such as nbproc or nbthread, you could go ahead and comment those out, as HAProxy will automatically configure itself against all available cores. You know, the best way is you can use the built-in configuration checker, where you can pass your configuration file with -f, so it would be -f HAProxy.cfg followed by -c to do a check, and that will point out any errors or warnings about your configuration.
Okay, so there is another question. Does there exist an AES_GCM_ENC, which would be the counterpart for the AES GCM DEC?
No, not yet, but the community user who contributed this converter said that he could see creating one in the future, but no, not right now. It's only available for decrypting.
So we have another question. So what recommendations do you have for alerting from HAProxy when it detects that a server is down? So maybe this is more like kind of third-party systems that plug into HAProxy.
Yeah, well, you can also use the HAProxy can be configured to send email upon various events that happen within it. So if you check out the documentation and look for mail, you'll be able to find some info regarding that. Other than email, HAProxy cannot communicate to you that a server is down. However, you can take advantage of the runtime API to dump some of this information, or potentially using the stats page with the CSV output. And that will provide the information to tell you whether HAProxy has detected a server as down. And you can easily hook into the runtime API over TCP or Unix socket, and it can return the data either in a plain text, or it can also return it in JSON.
Another question, the question is, have there been improvements to multi-threading as part of this release? So maybe you could talk a little bit more about what changes there were related to multi-threading.
Yeah, so the biggest change around multi-threading in this release is the ability for HAProxy to configure itself against all available cores. When HAProxy 1.8 was released, it added multi-threading support, but it was found that you wouldn't see any significant gains with more than 4 threads configured. HAProxy 1.9 expanded on this by allowing you to use as many threads as you have cores available. And again, HAProxy 2.0 improved on this by automatically configuring itself against all available cores, as well as configuring the bind directives to spread themselves automatically against all these available cores.
So another question is, and this is related to SNMP. So the question is, does HAProxy have an SNMP MIB that can be pulled?
I don't think one is featured within the community version, but there is one that is offered within the enterprise version.
All right, let's see here.
While Nick is checking for further questions, I just want to let you know that if you think of a question after this webinar ends, feel free to join our Slack chat or IRC. They're both on the same location. Slack would be slack.haproxy.org to sign up, and it's relayed to the Freenode IRC network, #HAProxy. And you can find me there, and you can feel free to ask me further questions there after the webinar is completed.
So a question is, this person is saying that in HAProxy 2.0.1 that they were seeing that there was a problem with connections being closed in TCP mode. Where would a person go if they see something, a problem or an error? Where would they go to find help with that or to report that error?
So you can always find help again on our Slack or IRC chats, as I had mentioned. But if you believe that you're encountering a bug, you can submit a issue on the GitHub, which would be github.com/HAproxy. So you can go ahead and open a GitHub issue there, but please do not use the GitHub issues for help. It's mainly supposed to be used for bug reports and feature requests and things of that nature. So if you can also sign up to the mailing list where you would be able to ask questions or submit information there as well if you don't want to enter the chat.
So we have one other question that is about what are some of the topics that we're going to be releasing blog posts about, whether in particular if we're going to be talking about any sort of advanced usages of HAProxy. I can say that we're going to be featuring more about the HAProxy 2.0 release. There's going to be there will be a few more blog posts coming out about that, but otherwise we're really interested in what you in the community want us to blog about. I mean, I think this is something that we're really happy when people come and say, this is something we want to know more about, and we'll get people to write about those things.
Yeah, I agree with Nick. We do have some more blog posts coming out around various features and other releases that around 2.0. But if you have any suggestions that you would like to read about or you would like us to write about, feel free to contact us. Primarily, I'm best reached on the community Slack and IRC. Contact us with your suggestions, and we'll look into adding it to our content roadmap.
So yeah, if there's anyone else with questions, go ahead and get them in now. Give people just a little bit longer to see if there's anything else. Oh, so as a follow-up to the question about whether kind of an advanced usage, so that will be regarding stick table configurations. As we don't have something for that planned now, but now that you've said it, why not?
And I would just make sure that you've read our previous blog content on stick tables. We've released several different blog posts that cover some pretty good usage. If there's something specific that you would like us to cover around stick tables, please feel free to chat us up on Slack, and we'll look into that.
So this is another question. This is kind of related to what you had said before about being able to check whether a configuration is valid. But someone is asking again, what would someone need to do to start using 2.0, or if it just works out of the box?
It should just work out of the box, but just be aware again that you no longer need to manually configure nbproc or nbthread, and always before switching over, just double check your configuration with the -c parameter, which will run the configuration through a syntax verifier and make sure that it should work. -c will let you know if there's any warnings or errors with your configuration, but generally with new releases, we try as hard as we can within the community to make sure that they're backwards compatible.
So another question is, have there been changes other than the 4 GB max to the caching? What else has changed in regards to caching in 2.0?
That's the biggest change that has happened with the cache. Is it now supports a larger cache.
One other question is, I'm not sure if you mentioned it, but HTX mode, how has that changed?
HTX mode has just stabilized since it was originally released in 1.9. Many different bug fixes and various improvements have been made to it. There wasn't much of a functionality change per se, but it's been stabilized since 1.9, and it's now the default enabled within 2.0. So in 1.9, you would actually have to turn it on using an option directive, but in 2.0, it's enabled by default. And in the future, we intend that it will be the only way to operate HAProxy.
Is there a way to set up only HTTP 1 to a backend? I'm assuming this is if you've enabled HTTP 2.
With HTX you could do HTTP1 to HTTP1 or HTTP1 to HTTP2 or HTTP2 to HTTP1. It allows you to have any flavor of HTTP on the front end or on the back end.
Okay, I think that I think that's all of the questions for now. Again, I want to thank everybody for joining us. I mean, this has been really great, Daniel, for you to explain all these new features. I think we've covered a lot of ground today, and I mean, this is stuff that we're going to continue to cover in our blog. We are going to be having 2 more webinars in this series. Those are going to be on July 9th. We're going to be presenting the HAProxy Kubernetes Ingress Controller for high performance ingress. And then on July 16th, both of those are Tuesdays, we'll be presenting HAProxy Data Plane API True Dynamic Configuration Management. So make sure that you come back and join us for those. And Daniel, do you have anything else?
Nope, that's all. Thank you everyone for joining.
All right, thanks.